Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to go over how to write a molecular, complete ionic, and net ionic equation for weak and strong acids and bases. In this particular video we're going to go over calcium nitrate reacting with hydroiodic acid to make a weakly conductive solution. So let's get into this. So here we have calcium nitrate. Calcium nitrate is an ionic substance. So we need to go from the name to the formula. So you'll notice they give us the names, they don't give us the formulas. So we have to take that extra step to find the formula. So if you have trouble, or this is kind of, if you're rusty on how to name ionic compounds and how to name acids, please go to my videos on those topics, and that'll give you a good refresher. But I'm gonna go over it briefly here. So when they give you the name of an ionic substance, the name of the ionic substance basically is in two parts, and that's the names of the ions. So anytime you want to name an ionic substance, you take the name of the ions, put it together, you've got the name of the substance. So here we're working backwards. So here we have the calcium ion and we have the nitrate ion. So we just need to write the formulas with the charges for those. Here we have calcium. So calcium is in group 2, so we know that it has a 2 plus charge. So 2 plus. And how do we know that it has a 2 plus charge? Well, there's a couple of ways. One, we know it's in group 2, and so if we're following the rule of thumb that says that if you are in groups 1A, 2A, or 3A of the main group elements, then the group number is the same as the positive charge on your ion. And so if you're in group 2, you have a positive 2 ion. If you're in group 3, you'd have a positive 3. If you're in group 1, you'd have a positive 1. So here we have a positive 2. Excuse me. So the other way is to think about what we're the atomic structure of the atom that we're talking about. So we want to think about the valence electrons, and we know the number of valence electrons based on the group number again. So here, if you're in groups 1A through 8A of the main group elements, then that group number is the number of valence electrons you have in your atom. So if we know that calcium is in group 2 from the periodic table, then we know it has to have 2 valence electrons. If an atom is in group 7, then we know it has 7 valence electrons. So here we have 2 valence electrons. And so we want to think about, well, how is that going to react with other things? And so we want to keep in mind that all atoms want to be like noble gases, in that they have a complete outer shell, right? And usually that's 8 electrons, but not always. So here we have 2 valence electrons. It could either gain 6 valence electrons and have a full outer shell of 8, or it could just get rid of those 2 electrons. Which one do you think is easier? Yeah, it's going to get rid of the 2 electrons. So it's going to get rid of those 2 negative electrons. And so now you have 2 protons in your nucleus that are no longer being balanced with the 2 lost electrons, the negative electrons. So that means you're going to have now a 2 positive charge. So that's a way to think about it as well. So here we have a 2 plus charge. Nitrate is a polyatomic ion, so you need to know your polyatomic ions. I'm sure your teacher has given you a list of them to memorize. I have a video that goes over polyatomic ions, so please see that video as well as a refresher if you need it. But you need to know the polyatomic ions, you need to know their formulas, and you need to know the charges on them. So for nitrate, it's NO3 minus. And so there's the 2 ions. And so you'll notice that when that I have a 2 plus and a negative 1. So when we write our formula for an ionic substance, we want to have a neutral charge. We want to balance the positive and minus charges. So here I have a 2 plus and I have a negative 1. So I'm going to need 2 nitrates to balance the 2 plus charge. Another way you could do this is the crisscross method. And all that is you're going to take the number of the charge here and you're going to write it as a subscript over here. and you take the number 1 over here and you write it as a subscript there, and you write your formula. So here I have Ca. We don't write the ones. We don't write ones in our formula. So it's just Ca, and then I have 2 nitrates. When you have more than one nitrate ion, or I'm sorry, more than one polyatomic ion, you're going to have to use parentheses. So here I have NO3, and then on the outside, I'm going to put the 2. So if you have more than one polyatomic ion, you put the parentheses. If you only have one polyatomic ion in your formula, please don't put the parentheses. You don't need them. Okay, so here we have our first formula of our first reactant. And now we're going to have our second one, which is hydroiodic acid. So we need to know how to name our acids. So right away, because of the beginning hydro, I know that this is a binary acid. It's not an oxyacid. So it's not going to have oxygen in it. So remember, you have those 2 basic groups. You have your oxyacids that are named from, say, some polyatomic ion that has oxygen in it, like phosphate or nitrate or sulfate or sulfite, something like that. And then you're adding H to it. Here, the prefix hydro is a dead giveaway that this is a binary acid, and binary acids typically only have 2 elements, and one of those elements is hydrogen. It has to be hydrogen because it's an acid. So the other one is the other element is indicated by the rest of the word here, iodic, and that refers to iodine. So iodine is the other element. So this is Hi. So I'm going to write plus Hi. And the way you can remember how many hydrogens you need is you could think of this as an ion. And so iodine has a -1 charge. So in order to balance that, you need H plus, you need 1 H plus, so Hi. So there's our formulas. Okay, so now what do? We need to figure out our products. And so we want to make sure we understand that this Hi is a strong acid. So you have to know what the 6 strong acids are. So hydrochloric, hydroiodic, hydrobromic, sulfuric acid, and so on. There's 6 of them, sometimes 7. It depends on what textbook you read, but 6 usually is the number. So you need to know what the strong acids are. So that way, if you have something that's not among those 6, then you know it's a weak acid, and that's going to be important. But here we have a strong acid. Here we have just an ionic substance. Okay, so both of these are going to dissociate or ionize in water completely. Okay, and we'll get to that in a moment. All right, so how do we figure out our products? So we have an ionic substance here and we have an acid. Now, the thing about acids is that they are molecular substances. They're not ionic substances. However, when you put them in water, they will ionize, right? So they will become ions. So especially your strong acids. So when you do your when you figure out your products here, you could treat this as a double displacement or double replacement reaction. So how do you figure out the products of a double replacement reaction? Well, you have the 2 ions in the inside go together. So your nitrate and your H plus, your hydride ion is going to go together. And your calcium and your iodine are going to go together. So these 2 are going to go together. These 2 are going to go together. And all you need to do is balance the charge and write the formula. So you have calcium, which is a 2+ charge, and you have iodide, which is going to be a -1 charge. And so you're going to need 2 iodide ions to balance the charge. So you got Ca, and then you need I2. So that's going to form one possible product. And then you have here your NO3, your nitrate, and your hydrogen. That's going to come together. Now, I know that NO3 has a -1. This is going to be H plus, so I need a 1-to-1. So this is going to be HNO3. So now I have my reactants and my products, and now I just need to balance the equation and figure out what the states are. So here I have one calcium. I have two nitrates here, but I only have one NO3 or nitrate here. So I'm going to have a 2 there. Let me fix this so I can move that over. So that's a 2 there. So I have, now I have one H here, but I only have, I have two H's here. So I'm going to have to put a 2 here. So now I have two H's, and here I have two iodides and two iodides. So now I have a balanced chemical equation. Now for the states. So to figure out the states here, if it's an acid, it's going to be aqueous unless you're told otherwise. Then for the ionic substances, you're going to have to use your solubility chart or solubility table, kind of like this one. So I have a solubility table. So when you read your solubility rules, it will tell you that nitrates are soluble. And there really is no exception. I mean, there's very, very few exceptions, if any. So nitrate, if you have a nitrate, it is soluble. So that's going to be aqueous. So AQ. And here we said that this is a strong acid. So strong acids, the distinction between strong and weak acids is that strong acids will ionize completely in water, 100% or very close to 100%. So there is going to be none of this together in solution. It's going to be all separated in solution. So this is aqueous. So aqueous, okay, soluble, okay. And here we have calcium iodide. If we look at our rules for iodides, it says that all chlorides, bromides, and iodides are soluble except when you have silver, your lead 2 ion, or your mercury 1 ion. But we have calcium, so this is soluble in water. So that's going to be AQ. And this, ladies and gentlemen, is an acid. And we know this is an acid because it begins with hydrogen. That's a dead giveaway that you have an acid here. So what can you do? So we have an acid. We need to recognize what kind of acid we have here. This, ladies and gentlemen, is a weak acid. So the weak acid here, that's going to be important to keep in mind when we do our ionic equations. So when we have a weak acid here, that means that this is not going to come apart very easily. Most of this is going to be in together in this form. So let's get into this. And I just realized I made a mistake. So this is, okay, so here, nope, I'm good. False alarm. All right, so here, I made a mistake. This is not a weak, this is a strong acid, my bad. This is a strong acid. So here, this is going to come apart completely. So this is going to be aqueous. Okay. So then we do this is our balanced molecular equation. Okay. And so here, we're going to have we're going to need to write our complete ionic equation. So we're going to need to break these up into our different ions. So here we have, we're going to need to break this up. So this is aqueous. So these are going to break up into their ions. So we're going to set this apart. So we have Ca2 plus aqueous. And so when we write the ions, we're writing them with their charges and aqueous. So we have one here, so one there. I have two nitrates, so I'm going to write that as a 2. So you don't keep the subscripts when you're writing your ionic equation. So if you have a 2 subscript for your ion, it's going to become a 2 coefficient. So your subscripts for your ions become the coefficients, because remember, the subscript tells you how many of that ion you have in your formula. So that's going to become a coefficient to, again, indicate how many of that ion you have. If I keep the subscript here, that's as if I'm saying that those 2 ions are bonded together and they stick together, and that's not what's happening. Okay, so here I have 2NO3, and that's going to be a minus charge, and that's aqueous. And so here I have, again, this is going to be a strong acid, so that's going to be separated completely. So I have 2H plus and 2 I minus, so that's going to be 2H plus aqueous plus 2I minus aqueous. And so that is the reactants, and then I'm going to go to the product. So both of these are aqueous. And so here I have calcium 2 plus aqueous plus 2I minus aqueous. So the 2 subscripts become the 2 coefficient. Excellent. Okay, so now this is good. This is a strong acid, so it's going to break completely apart. So now it's going to be H plus, and I have 2 of them, aqueous, and now I have 2NO3 minus aqueous as well. So here's my complete ionic equation. And so now you can see that everything is separated. So we have our complete ionic equation. And you can think of this for the net ionic equation. We want to separate out the spectator ions. And you want to think of this as like 2 beakers, right? So here's my first beaker with my calcium nitrate in there, and my second beaker with my hydroiodic acid. And you can see that before I mix them, they're in their separate beakers. In this beaker, all I have are ions floating around doing nothing. Here I have ions floating around doing nothing. But then I mix them together in a single beaker. And what do you notice? I have all the ions are aqueous, so they're still floating around doing nothing. So if I have ions floating around doing nothing before I mix them, and then I have ions floating around really not interacting after I mix them, is there a reaction? No, there's no reaction here. So that's a dead giveaway that there's no reaction here. And so there's no net ionic equation, because the net ionic equation is formed when you take out the spectator ions that are doing nothing. Well, all of them are doing nothing. So there's nothing left after you remove all of the spectator ions. So there is no net ionic equation. So again, that should be an R. No reaction. Okay, so again, this is not going to be weakly conductive. It's going to be strongly conductive. So I hope this is helpful. If this made sense, if you enjoyed this video, please let me know in the comments, and let me know if you have any questions. Please hit the like button and subscribe to the channel and hit the notification button so you'll be notified by other videos that I put out. Thanks for joining me, and have a great day.